Okay, so for this one, we're going to combine systems with inclined planes. So when we look at this one, we have a 18 kilogram block on the left, and we have a 15 kilogram block on the right. So the instinct to say is that this pulley system is going to make this thing go counterclockwise around because 18 kilograms is bigger than 15. But what we need to recognize is that the incline plays a big role in the actual force exerted down the incline. So what we actually need to do before we move on with this question is actually solve for the x components of each block. So if I draw my vectors, we call this force of gravity 1, we call this other one force of gravity 2, and it's going to have an x component. Each of them are going to have an x and a y component. They also have a normal force, perpendicular to the surface, normal force. And there's also tension. Same rope, they're going to share that tension force. Equal and opposite. So before we actually move along, we're going to actually determine which way it's going. Especially if there's friction, it's very important because friction is always going to oppose the direction of motion. So if I actually want to see which way it's going to go, I'm going to solve for Fg1x. That's equal to m1g. And because it's along the incline, we have to multiply by that sine 30 degrees. So we actually get a value for the force. m1g. Yeah, that's 18 kilograms times 9.81 sine 30. So we get 88.29 newtons. Fg2x is going to be the second mass, it's 15 kilograms. It's on a 65 degree incline, so it's going to be times sine 65. So we have 15 times 9.81 multiplied by sine 65. We get 133.363 newtons. So clearly Fg2x is bigger than Fg1x, so it has to go clockwise around the pulley. So now we need to create our net force equation. And in the end, we're trying to find the tension in the pulley. But before that, we need to actually know what's the acceleration. So we're going to say ma. And our direction is this along the rope path. Okay, it's along the rope path. So the driving force, the thing that's making this thing accelerate, is that Fg2x. So force of gravity out block 2, but the x component. If we just follow along that path, so we know that Fg2x is down and to the right. That first tension is to the left. Second tension vector is in the direction of our direction of motion, so it's plus. And we have minus Fg1x because it's trying to pull in the opposite direction. If there was friction, now that we know which one the driving force is, we know friction is opposing the direction of motion. So a force of friction of block 2 and force of friction of block 1. So both of them would be negative because they both oppose the direction of motion. So those are both going to be 0 though because we're looking at a frictionless surface. The t's also cancel out, so all we are left with is ma. So I just put a little t there, talking about the whole system is being accelerated. So we get mta is equal to Fg2x minus Fg1x. So mta is equal to m2g, and that's going to be sine 65 minus m1g sine 30 degrees. So we actually already calculated those values. We have that 133.363 and 88.29. So that, if we just take those two numbers, minus 88.29, we get a net force of 45.0732 newtons. So that force is exciting the whole system. The whole system has a mass of 33.0 kilograms. we're just going to solve for our acceleration. So divide both sides by 33. You get 1.36585 meters per second squared. So that's our acceleration. For our final answer, if this was our final answer, we'd round that to 37 meters per second squared, and we'd stop there. But we're asking for what is tension. So I can look at either of these two blocks. I'm going to look at the 18 kilogram block or the 15 kilogram block. If I look at the 18 kilogram block, you can see that tension is pulling it that way, but the FGX is opposing it. Okay, FG1X. Overall, though, we know it's moving with some speed up and to the right. So let's next draw the tension force a bit bigger. So I can say, here's block 1. It's being accelerated by 1.37 meters per second squared. Some force T is pulling this block to the right, and it's being opposed by the weight of that block in the x direction. So if we rearrange this equation, we get T is equal to M1A plus FG1X, which was just that 88.29 newtons. So we can actually solve for that tension. Get 88.29 plus, it's an 18 kilogram block at 1.37 meters per second squared. So you get around 113 newtons of force in that wire. If we want to solve for, using the other block is inclined like so. Tension is pulling it backwards, but we have that Fg2x, that driving force. We know the velocity is in that direction. We say M2A is equal to our Fg2x minus tension. So tension is equal to Fg2x minus M2A. And this value was 133, so we're going 133.363 minus 15 kilograms times 1.37. And we get the same answer, 113 newtons.